In this lesson, we talk about sampling and camera samples, basically what is sampling and how it works. So first of all, let's open up our render setting window and set Arnold as our render engine. And in the main tab, we can see the sampling section. As we know, Arnold is a ray tracing renderer, and sampling and ray depth are the very core of Arnold as a ray tracer. That's why we start this course by discussing these principles instead of talking about lighting and shading, because without having a solid foundation about sampling and ray depth, discussing other subjects would be obsolete. When trying to render an image, Arnold needs to know the color value for each pixel so it can put together the pixels and give us the final rendered image. In order to do so, Arnold fires a lot of rays from the camera. They hit different objects and surfaces in the scene. At that point, they calculate the information on the surface and return some information about the objects, and this process can be loosely defined as sampling. So based on how many samples you have per each pixel, the render will be noisy or smooth. The more samples that you put in your scene, the higher the quality of your final render. I use two main concepts in this definition, rays and samples. And if I wanted to simply clarify the difference between rays and samples, is that the samples are the number of rays square rooted fired per pixel. Now, the number of these rays fired from the camera can be controlled using our camera or AA anti-aliasing samples. So camera samples control the number of rays per pixel that will be traced from the camera. This is a global multiplier. The higher this value, the higher the overall quality of your render is going to be. And the next logical conclusion is that your render time will also get longer when you increase this number. Remember, the actual number of samples per each pixel is the square of what you have defined here. So for example, if we set our camera samples to be 3 by 3 equals 9 samples per pixel. So 9 here is the actual samples per pixel. You can see that in this upper section of the sampling rollout, we can see the actual camera samples is 9. Another thing to consider about camera samples is it's universal. As I said, it's a global multiplier, an overall controller. So by increasing or decreasing this value, you are not only controlling the number of primary camera rays, you also change secondary ray types like diffuse, specular, transmission, and increase or decrease their quality as well. We'll be discussing these ray types also in this section later on. Now let's see how camera samples can be used in our scene to increase the quality of the render. We are going to be working with this scene. In your project files, you might get a simplified version of the scene, but you should be able to follow along just fine. To remind you, I'm using ACES workflow, so make sure to provide the proper config file in your color manager and set the IPR color space to output sRGB. You need to check out one of the lessons in the introduction section when we talked about setting up ACES briefly. Now let's open up render settings and go to Arnold render section, and let's set our camera, diffuse, specular, transmission, SSS, and volume indirect samples to 1. All the light samples in the scene are also set to 1, so we can see the pure effect of working with only camera samples in the scene. As we are using ACES and Cinema 4D's picture viewer doesn't support ACES workflow at the time being, we just stay in the IPR for now. I have docked the IPR window in my UI, and you can access it from the C4D2A menu from the extensions menu. In a future release, this might be removed from the extension menu and be added to the main menu up here. As I want to get my final render from the IPR and not interested in interactive rendering, at least for now, in the render settings and under system tab, we can turn off progressive refinement for IPR. And in the IPR window itself, turn off progressive render as well. So we get our traditional bucket rendering that only shows us the final pixel values without refining it over time. Now, if we run the IPR, it should start the final render. As you can see, because we only have 1 camera samples per pixel, the render is pretty noisy. The small lines and the edges are very jagged, and overall we have a very low quality but fast render. I can stop the IPR for now, and we can save a snapshot of this render to the picture viewer by clicking on this camera icon. I have configured the IPR snapshots to show me the sample values for all the rays, and the first number here is the camera samples, which is 1. Let's close picture viewer and let's increase our camera samples to 3 this time. Now, if you take a look at the camera samples, we have 9 samples because as you remember, the actual samples are these values squared. Always remember the universality of camera samples. That's why even though we have only one diffuse samples, the actual diffuse samples are 9 and diffuse value squared. So 1 by 1, 1 multiplied by the camera sample squared, which gives us 9 samples for diffuse calculations as well. We discuss diffuse sample in the next lesson. Now let's start the IPR again and take a look at the results. Now let's stop the IPR and take a snapshot. As you can see, when you compare this render to the previous one, the overall quality of our render has improved significantly. Not only the edges are less jagged, we have less noise, higher quality GI and specular reflections, and obviously now we have a much longer render. More samples equals to less noise but longer render times. And finally, let's increase the camera samples to 8 and start the IPR again. So obviously the render is much cleaner, but it took much longer. So you can see how increasing the camera samples can increase the overall quality of your render. But this is normally not how you increase the quality of the render in Arnold, because increasing the AA samples or camera samples not only increases the quality of our primary rays, it also adds more secondary ray samples, like for example diffuse, specular, and light rays. Always remember that when working with Arnold, the picture we have is physically correct. The light rays bounces and falls off like in real world. The only thing we are trying to achieve using these sampling options is how to reduce the noise amount and thus increasing the quality of our render. So we need to find out what is the origin of the noise. Diffuse rays, specular rays, transmission rays, light rays, camera rays, and increase the sampling for the ray types that causes the noise. Also, there are noises that come from certain effects like motion blur or depth of field. In those cases, you need to increase the camera samples to clear out the noise. We cover noise reduction extensively in one of the future lessons in the rendering section of the course. So in this lesson, we discuss sampling and camera samples, and in the next lesson, we discuss diffuse samples. See you there.